Let's take a look at arithmetic and whole numbers, the basics of arithmetic and whole numbers. So say we have 35,676. Well, that is read as 35,676. Well, the way you write that out is like this. So it reads 35,676. All right. Now, if we have a group of numbers such as 305, 356, 370, 365, and 350. If we want to put those in order, we're going to look at the numbers from left to right, and we're going to look at the first number of each group of numbers. So 3, 3, 3, 3. They all start with 3s, okay? So then we need to look at the second number. So there's a 0, there's a 5, there's a 7, there's a 6, and there's a 5. Well, because that's a 0, and it's less than 5, 6, and 7, we write that first. So 305, 305. Then we look at the two 5s. So we got a 5 there and a 5 there. So we have to take a look at the third number. Well, there's a 0 and there's a 6. The 0 is less than 6, so we write out 350. Then we do the 356, and then we know that the 6 is less than 7, so 365, and then 370. Okay? And if we have a number such as 56, 789, that's 56,789, and you were asked to tell you're asked to find out what the 6 stands for in this number, or what the 9 stands for. Well, the 6 is in the thousands place. So we got the ones unit, we got the tens unit, we got the hundreds unit, thousands unit, and the 10,000 unit. So 6 would represent thousands. Okay, that means that there's 6 units of 1,000, or there's 6 thousands in this 6,000 units in this number. And then if we look at the 9, that is in the ones unit. So there's 9 ones in this number. All right. The 5 would be 5 10,000s, so 50,000. Okay. All right. And then let's take a look at some other numbers. So say we have 1, 2, 3, 4, and 5, 6, 7. I mean 6, 6, 7, 6, and then 5, 6, 7. 5, 6, 7. Okay. Is this number odd? Is this number even? Odd, even? What is it? Well, an easy way to look at, an easy way to determine if they're odd or even is to look at the last digit of the number. So this ends with 4, which is even, so the whole number is even. This ends with 6, which is even, so the whole number is even. And this ends with 7, which is even, so the whole number is odd. I mean, not 7. 7 is not even. 7 is odd, sorry. Ends with 7, which is odd, so the whole number is odd. Okay? All right. Okay, so let's take a look at prime and composite. So say we have 56. Well, 56, that is a prime or a composite. Well, I would say it is a composite. Why? Well, the definition of a prime is that a prime number is a prime if it can only be divided by itself or 1 and get a result which is a whole number. So, for example, 56. 56 can be divided by 1, and it can also be divided by 56, but it can also be divided by a couple other numbers. For example, it can be divided by 4, and it can be divided by 7, and it can be divided by 8, and it can also be divided by let's put it in order. It can also be divided by 2. Okay, and it can be divided by 14 and 28. Okay, those are all the different numbers that can go into 56. So if it was just 1 and 56, then yeah, it'd be prime. But in this case, it's not. What about 13? 13 has can be divided by 1, and it can be divided by 13, and that's it. No other number. So that would be a prime. So prime. Okay, and this is the reason why. Okay, and this is a composite, and this is the reason why it is a composite. All right, so let's take a look at another number. Okay, say we have 41. Well, 41 is also a prime. Why? Because it can only be divided by itself and 1. All right, so let's take a look at another number. This is a little more tricky. Okay, this is a composite. All right, one would think that it's not, because it looks like nothing off the top of my head, or probably your head, can go into that. 2 doesn't go into that, 3 doesn't go into that, 4 doesn't go into that, 5 doesn't go into that, 6 doesn't go into that. All right, 161 cannot be divided by any of those numbers, but it can be divided by 7. So the factors of 161 are 1, 7, 23, and 161. Okay? All right. Let's take a look at rounding. So rounding, say we have a number of 2, 5, 5, 6, 8. All right. Oops. There we go. So if we wanted to round that number to the nearest thousandth mark, we look at this 5 right there. That's in the thousand mark. And then we look to the number directly to the right of it. If that number is greater than 5 or greater, I should say, you're going to round up. So it's going to be 26,000. But if that number was smaller, say that number was a 4 instead, so if I change that to a 4, then this would just be 25,000. You'd leave it at 5, and then you'd make the rest 0. So again, if it was a 5, you would change this 5 to a 6, and then make the rest of the numbers 0. Okay? But what about something a little bit more tricky, say like 699? Okay? If I want to round that to the nearest tenth, so here's the 10th place, all right? Well, since we use a number system of 0 to 10, right? 9 is just below or just behind the 10. So if we round this 9, we're going to have to move this 6 as well to a 7, okay? And do we round it? Yes, we do, because there's a 9, there's another number directly to the right of it, which is 5 or greater. It's a 9, so we're going to round this to 700. Okay? All right. So let's take a look at a little bit of input and output. Let's take a look at input and output and graphs. Now we're gonna pause the video and we're gonna make several different parts of this video. All right. So this is part 1, and I'm gonna make part 2.